like.
Wait, are you gonna?
No, we're gonna. This is what we're gonna do together. Okay, so let's go ahead and look at these. Oh, you need to borrow one from someone, please. Someone have a pencil Sean can borrow. Okay, so listen up. I want to get through as much as we can today because we're going to e-learning a little bit. Okay, so as you're looking at these are your notes. These need to come with you every day for the next couple weeks. You are not going to need your book necessarily unless you have makeup work that you might have time to work on. You need to bring your notes with you every day, and you need to bring your device, because if you get down with the numbers that I assign you, you are going to work on ALEC. So I'm not going to give you as much homework necessarily, because I want you guys to have some time to finish ALEC and finish strong with ALEC. So this packet needs to come with you every day, and your device needs to come with you every day. Your book doesn't necessarily need to. We'll collect it in a couple weeks. Why is the Glassford in here? I don't know. She's been absent the past couple days. So let's go ahead, guys. Listen up. Okay, so let's go ahead and look at the first couple, 1 through 6. So as I look at 1 through 6, we are simplifying. So this doesn't really go in any order. It's all mixed together. This follows the same order as the review packet I'm going to give you once we get done with it. So you will be able to look at your notes, and it will look very similar to the review packet I'm going to give you to do as homework. So as I look at the simplifying radicals, what do I always want to look for when I'm looking for simplifying radicals? We did it in chapter 10.
I would rather do it, but I don't know how to say it.
That's fine. Should I take a stab at it?
I don't know. Don't you have to find one that multiply? You have to find a perfect square less than that multiplies perfectly into it?
Yes, so we are looking for a perfect square that goes into 128. So everyone grab a calculator if you don't have one. And we are going to look for the biggest perfect square that goes into 128. So go through, if you don't know what the perfect squares are, get out your chapter 10 notes and start dividing them by perfect squares until you find the biggest one that goes into 128. So start taking 128 and start dividing it by perfect squares. So what is the biggest perfect square that goes into 128? 64 times what? 2. So we are going to rewrite it as the square root of 64 times 2. This is what we did in chapter 10. Should look familiar. Now, what is the square root of 64? 8. I bring it out front. So that's 8 square root of 2, and that is your answer. So the reason that we want a perfect square underneath there is because I can actually take the square root of it and get a whole number, and I can bring it out front. So 8 square root of 2. Okay, let's try 320. So as I look at 320, what is the biggest perfect square that goes into 320? I don't know off the top of my head, so I'm just going to take 320 and start dividing it by things. By perfect squares. Is it 64 again? So 320 is the square root of 64 times 5. Square root of 64 is what? 8. So this is going to be 8 out front, square root of 5. Good. Let's look at 4 real quick. Okay, 4 we are doing the same thing, except we're throwing in exponents and variables. Now, to deal with exponents, I'm going to divide the exponents by 2, and we'll deal with that in a second. So let's look at 288. 288 we do just like we did with the past 2. So start dividing it by perfect squares. So what is the biggest perfect square that goes into 288? 16 times 18. That's not the biggest perfect square. So start taking 288 and start dividing it by things. 16 is a perfect square. It's not the biggest one though. 36 and 8. Still not the biggest perfect square. So start taking 288. Let's go ahead and do this. Let's rewrite it. Square root of 36 times 8, x to the 4th, y to the 4th. We can go ahead and do that. because I want to show you, even if you don't get the biggest perfect square, as long as one of them is a perfect square, you can get started with it. You might have to do it twice, but you can at least get started with it. So 36 times 8. What is the square root of 36? 6. So I bring it out front. Okay, let's start. Square root of 8. So we're going to leave that as the square root of 8. I'm going from left to right underneath it. Now my exponents, I'm going to divide them by 2. So 4 divided by 2, how many whole times does 2 go into 4? 2. So that becomes your remainder out front. So x squared. How many whole times does 2 go into the y to the 4th? 2. So that becomes your remainder, or your exponent out front. So however many whole times 2 goes into the exponent is the exponent out front. Now the remainder is the exponent on the inside. So as I look at this, will there be any remainder left on the inside? No, because the exponents are what? Even. Keep saying stuff. Yeah, they're even. Anytime I have an even exponent, you're never going to have a remainder. If it was an odd exponent, my remainder was what? 1. Okay? Now, is this all the way simplified yet? No, because there's a perfect square that goes into 8. So what is the perfect square that goes into 8? 4 times 2. So if you don't find the biggest perfect square, you're going to have to simplify it twice. What is the square root of 4? 2. So when I bring a 2 out front, what do I do with the 6? So that's 12x squared, y squared, square root of 2. Good. There goes all my markers. Okay, any questions on that? Okay, let's try 6 real quick. So as I look at 6, square root of 252xy squared. So let's start taking 252 and start dividing it by perfect square. Now it's even. So 25 probably wouldn't work. 100 isn't going to work. So since it's even, I would start trying even numbers. 16, 36, 64, 36 and what? 7? Okay. So rewrite this as 36 times 7, xy squared. Square root of 36 is what? Square root of 6, so that goes out front. Leave a space. I was going from left to right, so I did the square root of 36 with 6. Cannot take the square root of 7. And now I have to deal with exponents. This is x to the first. How many whole times does 2 go into 1? It doesn't go into 1 any whole time, so there's no exponent out here. So it just stays x to the first in there. So that one's kind of tricky. This is an exponent of a 1, so how many whole times does 2 go into 1? None. So there's no exponent out front, and it's just x to the first inside there. How many whole times does 2 go into 2? Once. That's my exponent out front, so y to the first. What's my remainder? If I take 2 into 2, what's my remainder? What was that? Nothing, because it's an even number. So 6y square root of 7x. Okay. Any questions on those? Okay, let's go ahead and look at 7. So as I look at 7, we are dealing with exponents. And we worked on the warm-ups last week with exponents. When I multiply what do I do with my exponents? When I multiply, I do what with my exponents? Add. When I divide, I subtract. So what you want to do first with these is you want to multiply where it tells you to multiply first. So as I look at number 7, I'm going to multiply across the top first. Because you want to multiply, get the top and bottom both simplified, and then we'll go through and divide. So if I'm multiplying on the top, I have 4 times 1, so that's a 4. U to the, add your exponents because I'm multiplying. So negative 3 plus negative 4 is what? Negative 7, and then v to the negative third. So go ahead and multiply first, whether it be in the top or bottom. So multiply your whole numbers, add your exponents. The bottom is going to stay 2u to the 4th, b to the 4th. Now we can go through, we are dividing. So if I'm dividing, I do what with my exponents? If I'm dividing, what do I do with my exponents? Subtract them. So let's go ahead. Your whole numbers, your coefficient, you divide like normal. What's 4 divided by 2? 2. So that's going to go up top. We always start fraction because this would be 2 over 1. So you could put a 1 on the denominator if you want to. And we are going to subtract my exponents. You always start it up at the top. What is negative 7 minus 4? So negative 7 minus 4. Negative 11. So that's u to the negative 11. Always start it back up at the top. And then the v. What is negative 3 minus 4? Negative 7. Any questions on that so far? I do not like negative exponents. You cannot have negative exponents in your answer. So what do I do to get rid of negative exponents? Move them to the bottom. So I'm going to have a 2 on top. That 2 isn't to a negative exponent, just the u and the v are. On the bottom, I'm going to have u to the what? And v to the? That's my answer. So quick review on exponents. It's been a little while. That's why we're doing this review. Okay. Any questions so far? Okay, let's look at 10 real quick. So as I look at 10, we notice that the top and bottom both aren't simplified yet. So we need to multiply on the top and bottom and see what we have. So on the top, if I multiply on the top, what is my coefficient going to become? 8. 2 times 4, 8. And then we go through my exponents. X to the, add your exponents, 0 plus a negative 3. Negative 3. And there's no other y, so it's just y to the negative 3rd. We'll deal with the negative exponents in a second, but just add them. On the bottom, when I multiply, my coefficient is going to be what? Coefficient is going to be 4. So you have a 4. This is a 1 here if you want to put it. So 1 times 4. And then go through and add your exponents. X to the, what's 0 plus negative 4? Negative 4. And then y to the 6. 3 plus 3. 3 plus 3, y to the 6. Okay, any questions so far? Okay, let's go through and divide it out. So my coefficient, when I divide it out, is going to be what? What's 8 divided by 4? 2. So it's going to be a 2 over 1. And then subtract your exponents. Now be careful with this. If you need to write your exponents out, always start it up at the top. So x up at the top. Negative 3 minus negative 4. So plus, plus. So what's negative 3 plus 4? 1. So x to the first. I'm not going to put it. And then let's look at my y's. Negative 3 minus 6. Negative 9. Plug in your calculator if you need to. Now I don't like negative exponents, so to get rid of that negative exponent, where do I move it? So my final answer will be what? 2x over... No, because when I move it to the bottom, it becomes positive. So y to the 9. Yep, good. Okay, any questions on that? Okay. Let's go ahead and look at 12 through 20, the next section. These are factoring ones. So 12 through 14 are factoring out the greatest common factor, the common factor, or the GCF, as you might see it. So if you have your pink reference sheet out, which you should have in your notes somewhere, that is going to help you with factoring. So anytime it says factor, look at your pink reference sheet, and that will help you with factoring. Okay? So as I look at taking out the GCF, I look at 12, I want to find the biggest number that goes into all three of those terms. So as I look at all three of those terms, what is the biggest number that goes into all three of those terms? -7. Do I take out any n with it?
No.
No, because it's a greatest common factor. They don't all have n's in common. That last -7 doesn't have an n. So it's only a -7 is your GCF. So now you go through and you distribute it and see what's left inside the parenthesis. -7 times what gives me a -63? 9. I'm still going to have what left? End of the fourth. -7 times what gives me a +7? -1. So -1 into the third. And then -7 times what gives me a -7? +1. And you can always distribute to check it again and to see if it is correct. So 12 through 14 was only just take out the GCF, the greatest common factor. You don't have to go any further. Okay, questions on that? Okay, let's look at 14. Okay, I want to factor out the greatest common factor. So this is like step 1 on the factoring reference sheet. As I look at my coefficient, 8, 12, and 20, what is the biggest number that multiplies into 8, 12, and 20? 4. Now, is there going to be a p with it? Yes, because they all have some sort of p in there. P to the 5th, p to the 6th, p to the 7th. How do I figure out what exponent goes with the p? It's the smallest one. So the GCF is going to be 4p to the 5th. You always pick the lowest exponent. Good. Okay, let's think about distributing. 4 times what gives me 8? 2. And I started with 8p to the 5th, and I took out a p to the 5th, so do I have any p's left? No. And then the next term. 4 times what gives me -12? 4 times what gives me -12? -3. I started with p to the 6th, and I took out p to the 5th, so I'm going to have p to the what left over? First. So just -3p. 4 times what gives me 20? 5. P to the 5th. If I started with p to the 7th and took out p to the 5th, I have p to the what left over? Second. So that's going to be p squared. And that is your answer. So 12 through 14 was just taking out your GCF. Okay, factor each completely. Your pink reference sheet is going to be helpful for this. If you do not have it out, get it out. We spent over about a month factoring. This is stuff you need to know how to do. So if you have your pink reference sheet, you need to get it out. Okay, as I look at factoring these, let's look at 15. So as I look at factoring this on the reference sheet, what is the first thing I always look for to factor?
Are you doing purple or pink?
Pink. Purple is quadratic equations. Pink is reference sheet, but factoring.
I don't remember pink.
It should be pink. Or it might be
Is
another
it yellow?
Oh, yellow. Sorry, yellow reference sheet. Pink is calculus. Yellow reference sheet. It says factoring reference sheet. No, that's the quadratic.
When you said pink, I looked.
No, I think it's P. Or purple. Purple reference sheet. Sorry, purple. Factoring reference sheet. Purple. Sorry, I was wondering why none of you were doing it. Okay, as I look at factoring this, the first thing I always look for is a GCF. So if I look at number 15, is there a GCF for 4b squared and -1? Is there a GCF for 4b squared and a -1? No. So I move on and I look at how many terms it has. How many terms does 4b squared minus 1 have? 2. So which part of the reference sheet, which box am I going to be looking at that has 2 terms? Do what? Yeah, the very left box. Difference of perfect squares, the binomial. So I want to see, is this a difference of perfect squares? First of all, is this a difference? This is not rocket science. Is this a difference? Is this a difference? What does difference mean?
Subtract.
Subtract. Is this subtraction? Yes. Don't make it harder than it is. Are these perfect squares? Now that means is, can I write both of them as perfect squares? So what squared will give me 4v squared? 2v. What squared will give me 1? 1. You don't have to worry about the negative because it's already in the middle. This is not factored. Factoring is writing it as multiplication. So how do I write my final factored form? Look at your reference sheet. Very far left box. What do I do with the two terms in the parentheses? Look at your reference sheet, very far left box. What did I do with those two terms in the parentheses?
Oh, so take the parentheses, 2v minus 1 plus, and then another 1 has 2v plus 1.
Yep, subtract them and add them. 2v minus 1, 2v plus 1. This is something as you go into Algebra 2 and Geometry, you are expected to know how to do. That's why we spent a month going over them. So you'd add the two things in parentheses and you subtract them. Good. Okay, now let's look at 19. If I look at 19, is there a GCF? N squared minus 8n plus 16. Is there a GCF? No. So then I move on and I look at, okay, which box am I going to use to factor it? How many terms does it have? 3. So I have two options, the easy way or the hard way, the shortcut or the long way. So as I look at this, which way do I use? The shortcut, so the bottom left box, or the bottom right box, the long way? Huh? Why the bottom left?
Because the number in front of 1.
Yep, the number in front of n squared is a positive 1, so I can do the shortcut way, bottom left. How do I get started on the shortcut way? Not yet, before I get started on that. How can I get it set up? Look at your reference sheet. Two parentheses, put n's in front. Now, once you have it set up like this, because it's a shortcut, how do I find the numbers that go with them? I need two numbers that multiply to give me what? And add to give me what? What? Negative 8. So what are two numbers that multiply to give me 16 and add to give me negative 8? Now if they have to multiply to give me a positive, what do the signs have to be? Negatives. So what are two negative numbers that multiply to give me positive 16 and add to give me 8? Negative 8. I know, I hear it. What is it? What are two numbers that multiply to give me positive 16?
Negative 4, negative 4.
Yep. So n minus 4, n minus 4. Hello? Hey. Yes? Yes? See me in chat? Okay. Okay, I'll send it out.
I'm just going to the front office because I'm not going with that.
Okay, well, you can figure it out with them. Okay, so n minus 4, n minus 4 are your two numbers. Now, do I set them equal to 0? Read your directions. Do I set them equal to 0? What's your direction say? What's your direction say? Factor. Factoring means writing it as multiplication. It doesn't say solve, so you do not have to set equal to 0. It's just factor, so something times something. Okay, one more example. Let me go through 18 with you. Okay, as I look at 18, is there a GCF?
No.
No. So I move on to step 2. How many terms does it have? 3. Is it going to be the shortcut or the long way?
Long way.
Because there is a number in front of 25. Or there's a number in front of m squared. So we're going to have to go through the 4-step way. And I have the steps written on your reference sheet. Step 1. I need to multiply what two things together? So 25 times 1, which is what? 25. Step 2, I need to find two numbers that multiply to give me 25 and add to give me what? Negative 10. Okay, let me get those. So let's think. Two numbers that multiply to give me a positive 25 and add to give me a negative 10. Negative 5 and negative 5. So I found the two numbers. Once I find those two numbers, step 3, what do I do with those two numbers? Plug them in for your middle term. So instead of negative 10m, I have negative 5n minus 5m plus 1. So once you find those two numbers, you replace the middle term with it. And then step 4, how do I factor from there? Group them. 4 terms, you always use grouping. So what is the GCF of 25m squared and negative 5m? 5m. So I bring it out front. 5m times what gives me 25m squared? 5m. 5m times what gives me negative 5m? Negative 1. Now as I look at this, I need my parentheses to be the same. Anytime I do grouping, I need the parentheses to be the same. So what do I factor out of negative 5m plus 1 to make it a 5m minus 1? What do I factor out to change the signs? Negative 1. So if I factor out a negative 1 times 5m gives me a negative 5m. Negative 1 times a negative 1 gives me a positive 1. Now since my parentheses are the same, how do I write my final answer when I do factoring by grouping?
Could you do like make like a parentheses 5m minus 1 and then put like squared?
Yeah, I'll write it out like this first. So what's in the parenthesis goes in 1, 5m minus 1. What's in the outside, which is also a 5m minus 1, goes in the other one, which anytime you multiply the same thing by itself, that's the same thing as squaring it. So you can write it as squared if you want to. I wouldn't take off, but either way, either of those two answers would be fine. Okay, so quick review on factoring. Look at your reference sheet. That would be helpful as well. Okay, so these are your notes. Bring them with you. So you need to bring these and your device with you.